Notes for volume 3. We're doing discs and washers up the vertical, and this is example 2. So in example 2 we're looking at the area bound by the function y equals square root of x and the function y equals negative 1/2 x plus 4. The first thing we're going to do is we're going to find the volume that's created when you take this bound area in here and rotate it around the x-axis. And this is a review problem. We're taking, we end up needing to do this in two pieces. We're first going to take that area and rotate it around the x-axis. The integral for that is going to be from 0 to 4 pi, and then the radius of this is defined by our red function, and that's going to be this is for you, Jacob. This is going to be the square root of x squared dx, because we're doing this with our discs coming along the horizontal. Each disc has a width of dx. And then to this, we're going to add the second integral, which is going to be the integral when we take this piece right here and rotate it around the y-axis. And that integral will be pi, excuse me, we're not integrating this, we're not rotating this around the y-axis. Not yet. We're taking this and rotating it around the x-axis. So we're going to rotate this around the x-axis, get a series of discs. Each disc is going to be dx wide, and we're integrating from 0, excuse me, not 0. We're integrating from 4 out to 8. And the radius of that disk is defined by the second function, so it is negative 1/2 x plus 4, and that gets squared, pi r squared. Pi r squared for each one of those disks, which are dx wide. Right? So that's A. And now we're going to look at, instead of rotating around the x-axis, we're going to look at rotating around the y-axis. Alright, so now if we're going to rotate around the y-axis, we're going to end up with, in this case, a washer, and the outer radius of the washer is going to be defined by the blue function, and the inner radius of the washer is defined by the red function. And we are integrating now from, we're up the vertical. So we're starting at 0 and we're going up to a height of 2. So our integral, again, is going to be pi on the outside. We're integrating from 0 to 2, and I'm going to put out here at the end dy, so that we remember that each one of these washers we have here is dy thick. Let's see if I can draw a little thickness here to our washer. And there's a little thickness on the inside here. Not bad. So now we want to figure out first what's the outside radius of this washer. So the outside radius is from here all the way to the y-axis. And we want that radius, right, is that distance right there. And that distance, right, so a point right here, if we're finding this point, and what we're interested in is the x coordinate of this point to figure out how much that radius is. We want this to be with respect to y, so we want to write this x coordinate in terms of y. So if the function, here we'll do this over here, if the original function is written in terms of y, right, so minus 1 half x plus 4, we then take this and we're going to solve it for x so that we can figure out what the x coordinate is in terms of y. So this is going to be y minus 4 is equal to minus 1 half x minus 2 is equal to y minus, so x is equal to negative 2 times y minus 4, and actually let's just write this in terms of the positive. So that x coordinate up here is going to be, so this will be 2 times 4 minus y, comma, y. So then the radius of the outer function is this right here. Okay. And that's what gets squared down here in our integral. So this would be 8 minus 2y, just distributed the 2 through, squared, and then minus, and then we want to figure out what the radius of this inner function is, and we can again do the same thing. Give myself a little space here. That second function originally is written in terms of y. Y is equal to x squared, and we want to write it in terms of x, so we would get x is equal to, oops, sorry, it's not the original function. Y is equal to the square root of x. My bad. This is the function we're looking at. It's y is equal to the square root of x, which means that x is equal to y squared. So then over here in my integral, this is y squared squared. The third example, so let me clean up my graph here and we'll get to the third example. So in the third iteration of this problem, we have the axis that we're rotating around at the line x equals negative 2, which is this black line that I've drawn here. Our washers then, the outside radius of the washer is defined by the blue function, and the inside radius of the washer is defined by the red function. I've gone and rewritten the coordinates of a point on the blue function in terms of y. So the x coordinate is 8 minus 2y. We did that before. And then in the red function, the x coordinate is y squared. So then if we're looking for the radius of the outer circle of the washer, that radius is from negative 2 out to this point. x coordinate of that point is 8 minus 2y. So this whole distance here is going to be 8 minus 2y minus negative 2. And then the radius of the inner circle in the washer is right here, which would be y squared minus negative 2, or y squared plus 2. And then knowing those, we can write our integral here, which is going to be pi. We are going again from 0 up to 2. The outer radius is going to be 8 minus 2y plus 2, or 10 minus 2y squared, minus the inner radius, which is going to be y squared plus 2, all of that squared. And again, this is when we're rotating around the y-axis, or we're rotating around a vertical line. Our washers have a width of dy. We are integrating up the line x equals negative 2. And we are done with example 2.